Now we will take a look at a much more advanced question for topic 3, the laws of motion. Two objects are connected by a light string that passes over a frictionless pulley as in the figure. Draw free body diagrams of both objects if the incline is frictionless and if m1 is equal to 2 kg, m2 is equal to 6 kg, and theta is equal to 55 degrees, find A, the accelerations of the object, B, the tension in the string, and C, the speed of each object 2 seconds after being released from rest. Let's firstly draw the free body diagrams of both objects. Then in this case, I will be drawing the free body diagram inside of the figure, given that the figure is large enough for us to put as many information as possible. For the first one, mass 1 equal to 2 kg, definitely there will be weight downward direction, so W1 is equal to M1 multiplied with G. Another force will be the tension in the string. Remember, tension is always directed away from the mass. With that, we're going to draw the acceleration, and then in this case, it will be moving upward. So A is directed upward for mass 1. The reason being is because mass 2 with much larger mass, 6 kg, will be pulling it in that direction. So acceleration of mass 1 is relatively upward, while mass 2 will be relatively downward. Moving on now, let's proceed to drawing the free body diagram of mass 2. First of all, we're going to be drawing the weight, W2, which is equal to M2 multiplied with G. And then, because it is rested on this inclined surface, it will also have normal force, which is 90 degrees or perpendicular to the plane of the surface. And last but not least, it will also experience another force, which is going to be tension, which again directed away from the mass. We are dealing with a much more complex situation here, and then with that, we're going to draw reference axis. So this is my x and y axis for mass 1. So everything is along the y-axis for mass 1. However, for mass 2, I'm going to draw the axis in this orientation. So this is y, and then this is going to be the x-axis. The reason is to simplify our solution so that the acceleration is only of a single axis, which is the x-axis. So now, with mass 1, because it is of a single y-axis, we're going to be applying the Newton's second law of motion. And then, since it experienced acceleration, we will be applying the second Newton's law of motion, which is total force is equal to ma. So we're going to list down all of the forces, which is going to be the tension as well as W1, which is the weight of mass 1. Adding this together requires us to not only add the magnitude, but also to care about its direction. The tension is towards the positive y-axis, so it will be positive, and then the weight downward direction or negative y direction, so it will gain a negative sign. And then again, we add the two forces together. So positive T plus with negative W1, it is equal to, the mass here will be mass 1, acceleration will be positive going upward, and then now we can substitute with its rightful formula. The only formula that we can substitute here, which is going to be the equation for the weight, W1 is equal to M1 multiplied with G. It is equal to M1 multiplied with E. So mass 1 is equal to 2 kilogram. Multiply with 9.8, it is equal to mass 1 again 2 multiply with E. So our equation will be simplified to just T minus 19.6 equal to 2A. So this will be our first equation. Now let's take a look at mass 2. So as you can see here, we have our reference axis, the x and y here, and then all of the forces are in either x and y axis. For y it is the normal, and for the x it is the tension. However, W2 will have both x as well as the y component. So now I'll be drawing the component of W2, which is going to have, this one is going to be W2y, and another one will be W2x. Looking at the question, we have theta is given 55 degrees. So separately, I can draw the triangle, right angle triangle here, 90 degrees. And then this side is the base of the triangle, hypotenuse, and the vertical side of the triangle. Moving on, the corner here will have 55 degrees, making the corner at the top here will be 35 degrees. The angle between the hypotenuse and the vertical side, which is 35 degrees, is going to be the same angle between W2x as well as W2. We can draw the vectors of the forces. This is W2, and then we have W2x, and I'm going to remove W2y from the top here to the bottom of the triangle. So this is W2y. And again, the angle will be 35 degrees. So if you recall, if you use cosine function, cos 35 degrees, it is going to be the adjacent, which is W2x over the hypotenuse, which is W2. And W2 will be equal to M2 multiplied with G. So in the end, W2x is equal to M2 multiplied with G multiplied with cos 35 degrees. With that, we're going to solve the x component of mass 2, which also has this acceleration. So total force is equal to MA for mass 2 using this black color marker. And then we see that there will be two forces on the x-axis, which is T as well as W2x. We're just going to list the forces for now. Remember, we are adding them together. right? T plus with W2x, which is the x component of W2. And then remember, we have to also give positive or negative sign according to its direction. For the tension, it will be towards the negative x direction, so it will be negative T plus with positive W2x because it is in the same direction as the positive x direction. Moving on, it is going to be equal to mass 2 and then multiply with A. A here is also positive because acceleration will have the same direction as the positive x direction. So moving on now, we can write down the equation negative T plus with W2x, which is M2G cos 35 degrees is equal to M2A. So now I will be substituting the correct value for each of the parameters. So M2 will be 6 multiply with 9.8 multiply with cos 35 degrees equal to 6A. So the equation will be reduced to negative T plus with 48.17 equal to 6A. So now we have two equations. So definitely we can solve question A until C by solving the two equations simultaneously. What we're going to do is, in this case, we're going to substitute equation 1 into equation 2. So I'm going to write down equation 2, which is negative T. So T, according to equation 1, is 19.6 plus with 2A. And then plus with 48.17 is equal to 6A. So I will give negative sign to each of the expression inside of the parentheses. So it will be negative 19.6 minus 2A plus with 48.17 equal to 6A. So I'm going to bring negative 2A to the right hand side of the equation. So it will be 6A plus with 2A, and then at the left hand side we can solve this by adding 48.17 to negative 19.6. So it will be equal to 28.57 equal to 8A. So A is equal to 28.57 over 8. The answer for the acceleration will be equal to 3.57 meter per second square. So this is our correct final answer for the accelerations of the object.